People always ask me, how is it like being a biochemist today? So it would be better for you guys to read this since for this assignment I have to make this video in less than 5 minutes, which is going to be hard for me. So since we're looking for the minimum acceleration needed for the car to go past the train, it's safe to assume that the final position of the train has to be equal to the final position of my professor's car. So in order to get the final position, in order to create a variable with acceleration, you have to use the equation. The final position equals the initial position plus the initial velocity times the change t plus the initial acceleration times the change in t squared of that over 2. Anyways, we're going to start to find t, and you have to use this equation. So because of this equation, we have to put the final position equal to the final position, since the final position of both entities are the same. And in order to do that, both sides of the equation have this part of this equation, except one side concerns the car that my professor is driving, and the other side concerns the train that my professor is trying to beat. So in red font, I already plugged in the number for you guys. So you integrate the integrals, which I already did for you in red font. But then since the bounds of the integral are the same variable with different subscripts, it's basically just delta t. So yeah. And now you have to do some algebra here. So add 6t to both sides, and then you subtract 20 delta t on both sides, and then you get 15 equals 10 delta t. And now you divide 10 on both sides, and then you get 1.5 seconds equals the change in time. So I forgot to tell you guys that the reaction time is half a second, or 0.50 seconds with two significant digits. And we have to find a new initial position for the car because we need to find when the car starts to accelerate. So as you can see, this is the equation we use. It originated from the final position equals the initial position plus the initial velocity times time plus the quantity of half the acceleration times time squared. And now we have to plug in the numbers for the car. So the car is at so the car's now final position is 45 meters from the crossing line, and then her speed is 20 meters per second. And then since this is before she starts to eat, she's going to get a constant velocity, which means this big conglomeration equals 0 since acceleration is 0, and 0 times basically anything is 0. So cut off, please. And 45 minus 20 is 25 meters, and that's how far she is from the crossing line, where she has to start yeeting across so that she doesn't get yeeted by the train. So now now that we calculated that the car is 25 meters when it started to yeet across the road, we have to plug it back here into this equation. So 20 so the final position again is 25 meters. And we subtract that by 20 meters per second, and then we multiply by the maximum amount of time the car has to yeet across the road, which is 1.5 seconds. Then we set that equal to the acceleration. So now we're looking for the acceleration. Earlier it looked like this, but I added this conglomeration to both sides. So yeah, and now excuse me, and now we have to calculate this. 20 times 1.5 is 30, and 25 minus 30 is negative 5, but we just need the absolute value of that, which is 5. And now you have to multiply. Now to make this conglomeration less of a conglomeration, we divide both sides by 2. So now this becomes 1, and this becomes excuse me, 10. Let me just erase this real quick. So now that you multiply both sides by 2, the left side is 10, and then the right side is just the acceleration times 1.5 squared. And remember that 1.5 is delta t. So anyways, now you have to square this one, and you get 2.25. And now afterwards, to finally finish this and go to fucking sleep, you have to divide both sides by 2.25. And when you do that to the right side, 2.25 times the acceleration divided by 2.25 is just the acceleration itself times 1. But if you get 10 divided by 2.25, you get 4.44444 2 hours later. Repeated meters per second squared. But then you only have 2 significant digits, since the minimum amount of significant digits is 2 in the word problem. So you have to use significant digits, or else the FBI would come to your house. This is your answer, and I can finally go to fucking sleep for once.